53. Again, this is going to reduce down. This is it really in practice is almost a factor label question again. But in addition to this, this is the process and the procedure we need to do to come up with a statistically weighted average, which is useful in this application and as well as others. It has many applications within the study of chemistry. This one gives us, this is how they arrive at the masses that are reported in the periodic table. And because of the sheer numbers of the atoms available in a mole, because of Avogadro's number, when you go to weigh something in the lab, this is actually accurate. You have to, in order to get 1 mole of a particular atom, you have to weigh out the statistically averaged atomic mass, not the weight of any particular isotope. Okay, so this is useful on many levels. So it's pretty straight up. What do I do?
Multiply the percent in
Yeah.
decimal form
by the atomic mass.
yeah.
The isotopic mass. Okay, by the relevant isotopic mass. So if the what he just said, for those who couldn't hear him, and perhaps the camera couldn't, was I'm going to multiply. I'm going to convert the percentage to a decimal form, and simply multiply. I could go further and use the definition of percentage. What is the definition of percent? What is the definition of percent? Parts per hundred. Exactly. But that would be overkill. It's much simpler. We don't want to make... Our objective is to simplify the problem, not make it more complicated than it already is. So we're going to simplify it by simply converting the percentage to a decimal and subsequently multiplying that decimal by the relevant atomic mass or isotopic mass. And then what do I do with the results of that? I'm going to add those two together. And that'll give me the statistically weighted atomic mass. This is how it's arrived at. And so this is pretty simple. What's 25% in decimal form? Times what? 37 AMU plus 0.75 times 35 AMU. And that's going to be equal to something. Now, on the actual test, so this statement alone is going to get you most of the credit. But on the actual test, you're going to have to do the calculation here. That's why you're going to bring scratch paper. So on my scratch paper, so what you're about to see me do, I'm doing on the scratch paper. You don't need to put this detail on there. You want this detail on there. And so on the scratch paper over here in the corner, I'm going to do multiply 37 times 0.25. 7 times 5 is 35. 3 times 5 is 15. That's 18. 14. 3 times 2 is 6 is 7. So 5, 8, 4 is 12. 9.25. And what do I do with the decimal? What? So everybody remember? Okay, so that means this part here is going to be 9.25 AMU. And now I can erase my scratch paper and I can do the other part of the calculation, which is 35 times 0.75. 25, 3 times 5 is 15, 17. 7 is 5, 30. 3 times 7 is 21, 24. 5 is 12, 6, and now I have. And that's this part here is 26.25 AMU. And now I'm going to add those two together. This is on my scratch paper again. 5 and 5 is 10. 4 and 5. 6 and 9 is 15. Equals 35.50 AMU. Okay? And that, and by the way, again, this is my scratch paper. So that would be what I would expect to see on the actual test. You want to clearly show me all the work, all the details, and it should make sense. Okay? Yes?
Do you want us to round up to 36?
Oh, okay. That's a good question. If you do, I'm not going to be as critical on this type of question with sig convention, but you've got a very good point. Absolutely. Yeah, so let's go to 36 AMU, because the significant figure convention would reflect that. Yes, thank you. Thank you very much. So sig figs, on a question like that, if I was going to be technically, on the sig fig questions, because I'm doing so much approximation in here, with most of the written problems, I'm not going to be that uptight about it. It may be 1 point out of 10 or something like that. But I'm going to have specific questions on sig fig convention, which are to test that. And the significant figure convention applies, by the way, to what quantities again?
Measured.
To measured quantities only. So that is, and you have to know how to use that within a particular calculation. So I will have separate questions that will test that. But yes, this would be a good option. This one would be a good one where the sig figure convention would be applicable. Yes.
So this one has two sig figs because that's the least amount.
Yeah, these were the measured quantities.
What if that
Well,
was
this
the
was
number?
also, these were both measured quantities, 75%, 35 AMU. What?
Right, and if that was like the number 40, 40 only has one significant figure. Right?
Yeah, well, it would be the way I noted it.
Okay.
If I said 40, then it would only have one significant figure. If it said 40 point with a dot, then it'd be 2 sig figs. Or if I said 4.0 times 10 to the 1 would be 2 sig figs.
Okay.
Okay? So those are the notations. Very good question. Any other questions about this before we move on? Yes?
I was just trying to eyeball this instead of actually going out and multiplying and dividing.
Uh-huh.
And for the first part, the 0.25 times 37 AMU, I could see that it's pretty close to 37, like the previous problem, I think 54. And it's pretty close to 36. So, since we're dividing by a fourth, it's divisible into 9.
Yeah,
And since it's one more
yeah,
to
yeah.
37, it'd be 9.25.
Yeah, I like
get
that.
a little confused when I go to the 0.75.
Well, 0.75 is 3/4, so you could
Yeah.
divide by 4 and then multiply times 3.
Okay. Do that again.
I like
So
that.
that's
What you were saying, so for those who couldn't hear what she was saying, she was just doing it ballpark in her head without doing that stuff on the side. And multiplying by 0.25 is the same as dividing by 1/4. And 1/4 of 37. 37 is close to 36,
Yeah,
which could be divided by 4
right.
9
then,
times.
Yep, and then
And-
one more.
And then 9 1/4, so that's 9 1/4. And then this one is 75%, or 0.75 is 3/4. So I could divide 35 by 4. Again, it's going to be 8. 8 and what? 8 3/4.
Would be times 3.
Yeah, 8 3/4 times 3. So 8 times 3 is 24. And 3 times 1/4. Yeah. So it comes out the same way either way. It's 0.75. And so yeah, you can get there. That's a good approach. I like that. Because you're doing in your mind, you're using your brain, and you're actually doing the algebra in your head. And so if that works for you, that's a good thing, and I want everybody to try and keep using your quantum computer. Because we have, each of us, one of those. And this is more powerful than any gizmo. So always do it that way. But because you're going to have scratch paper, you can do the thing over there to check your approximation. I like that. So please feel free to do any and all of the above. Okay? Any other questions on this one? No questions? Okay, over.